Now we are going to start on Module 3, Parking Studies, and let's start with an introduction. Basically, most trips starts as a pedestrian and ends as a pedestrian. We walk from home to our cars, then we drive to our destinations, then we park our cars, and we step out and walk to the final destination as pedestrians. So in both cases, we park car at origin and we park car at destination. That means there is a need for parking space at residential areas and at attractions or destinations, potential destinations. So the parking, okay, in this section what we are going to discuss, the parking generation and supply needs, the parking studies and characteristics, the parking facilities design and location, and how we build parkings, and the parking programs and the policies that we follow for parking. So we start first with parking generation and supply needs. So for parking generation, how many spaces are needed? Okay, so that's basically the key issue in determining parking. How many, in determining the size of the parking lot, we need to understand the parking generation or the supply needs. Okay, that depends of course on the facility that we are providing parking for. So parking generation relates the maximum observed number of occupied parking spaces to one underlying variable that is used as a surrogate for the size or activity level of the land use involved. As I mentioned, for example, in a shopping mall, okay, the parking generation will depend on the type of the activities and the floor area of the shopping center and so on. If we are talking about university, the parking space generated will be different. Okay, so here, for example, the measure, okay, the parking rated unit. Okay, for residential, we counted per unit, per dwelling unit. For apartment residential, okay, per unit, per dwelling unit also. For shopping centers, per 1,000 square of foot. For retail, okay, per 1,000 square foot. For hospital, per employee or per bed, because the number of beds determine the number of visitors that are going to be there. For medical and dental, per doctor. If you have a medical center that has whereas one doctor is only practicing there, it's different than having a clinic practice that you have maybe 5 doctors there. Okay, despite the floor area. Also the office, the per office. So that determines how, the number of patients that can be examined in the clinic. For hotels and motels, okay, per unit, how many rooms are there? Okay, for restaurant, per seat, number of seats in the restaurant. That determines the expected number of visitors to that, so you can expect how many vehicles needed or how many parking spots needed. Public assembly per seat, bowling alley and libraries and so on. So these are some parking generation factors. Okay, so for here, the average rate for residential, okay, low to mid-rise apartment, 1.2 per dwelling unit. That means each dwelling unit will need 1.2 parking spot. Okay, for high-rise apartment, okay, it's 0.88, per dwelling unit. That implies that not all residents in the units will have cars, but here it says that maybe in some dwelling units you will have more than one car. You get the point? For residential condominiums, apartments, 1.11 per dwelling unit. For convention hotel, it's 0.81 per room. For motel, 0.89 per room. For motel without restaurant and lounge, 0.5 per room. Industrial, okay. Light industry, okay, it's 1.55 per 1,000 square foot. Okay, for medical hospital, 1.79 per bed. This actually covers not just the visitors, okay, it covers the visitors, the physicians, the technicians, the nurses, and all the medical staff, everything. For medical dental specifically, it's 4.11 per 1,000 square foot, and so on. Again, in the zone regulation, parking generation and supply needs, zone regulations plays a major role in that. So the local zoning regulations generally specify the minimum number of parking spaces. That means even if you say that this facility needs 3 parking spots, there is a minimum that you must meet. And here, this is important, that we have the parking demand, and these the recommended zoning requirements. That's what we mean. For zoning requirements, these are the minimum, okay, that we must satisfy. Then, what are the critical issues in parking supply needs? Basically, the duration of parking, how long the person will park their car in that spot, and the accumulation rate. Okay, that's the rate of demand, how many per hour are arriving for parking, and the proximity requirements of parkers. That means the distance between the parking spot and, so that's the walking distance to their destination. Okay, so that's the proximity. Usually duration and accumulation are related characteristics. Yani these two are related to each other. Okay. For proximity, how far will parkers walk? Okay, that depends on how much they can tolerate. It depends on the trip purpose. So if the trip purpose was leisure, okay, going to the movie, going for cafe or something, you are not going to be willing to walk a long distance or park far from your destinations. But if that was for work trips or for going to school or so going to something important, you can you are tolerable to walk. The walking distance might be longer. For urban size also, if the urban area is a small community, people usually wants to park close to their destinations. But if it's busy big city, people are used to this. And this study shows that the 75% of drivers are within the 0.25 mile of their final destination. So the quarter mile, that's covers most of 75% of the drivers would like to park within this value. Okay, then we have another factor, which is basically the parking inventory. What do we mean with parking inventory? Okay, the spots available for parking, basically. How can we do this inventory? This inventory includes the following: observations of the number of parking spaces and their location, and the time restrictions on use of parking spaces. Some parking spaces, for example, have a time limit, maybe 2 hour maximum, or from 8 to 5 only, from 8 a.m. to 5 p.m. Okay, so there are some time limitations. So we have to find the parking locations and the time restrictions associated with this location. That means this parking is only available from 8 to 5. After that, it's not available. The type of parking facility. That means, is it street parking on the street, or it's off-street parking lot, or it's an off-street garage. Okay, so most parking data are basically collected manually, and this is going to be our second project for this course, by the way. This equation, okay, in calculating the parking inventories, is based on It's P, that's a parking supply in vehicles, and it's a summation over N, and these are I think this is number of spaces of a given type and time restrictions. T time that N spaces of a given type and time restrictions are available during the study period. Okay, and D, that's the average parking duration during the study period. That means in this area, the average, people parking their car and moving again, maybe 1.5 hours and so on. The N, that's the number of different types of parking. And F, this is insufficiency factor to account for turnover. That means it's usually between 0.85 and 0.95. What does it mean? It means F basically represents the case where someone looking for a parking, okay, and keeps circulating in the parking lot while someone is waiting to exit, and this guy, okay, doesn't see that spot available. So that's so that's a reduction factor for these kind of scenarios. Okay. So let's take this example. Okay, consider an example in which an 11-hour study of an area evaluated. Let me just take this all together. These are the equation, and let's try to solve this example together. So what the example is saying, it's saying that there was an 11-hour, which is an 11-hour study of an area, revealed that there were 450 spaces available for 12 hours. So here we have 450 multiply 12 hours plus 280 spaces available for 6 hours. 280 multiply 6 hours plus 150 spaces available for 7 hours plus 150 multiply 7 plus 100 spaces available for 5 hours plus 100 multiply 5. Okay, divided by the average parking duration in the area was 1.4 hours. So divided by 1.4. Okay, determine the parking supply in this case. Okay. Let's assume a sufficiency rate was of 0.9. So here, this is P. So let's calculate this value and see how many parking spots available per hour. So 450 multiply 12 plus 280 multiply 6 plus 150 multiply 7 plus 5 multiply 100 divided by 1.4 multiplied by 0.9. So we end up with 5,548 parking, okay, or vehicle. That means the current parking inventory can allow for this number of vehicles to park. But remember, those vehicles are not arriving at the same time. We have time span 12 hours, 6 hours, 7 hours, 5 hours. Okay, the maximum available parking Okay, at the same hour, you can adjust these values. Okay, so this is the total available for a day. Clear؟ واضح يا شباب؟
واضح دكتور.
Okay. So that was the example here, where an insufficiency factor of 0.9 were used. So that's here. Okay. And these are the forms that we use to fill this kind of information. Actually, hold a second. The accumulation and duration, that's another factor. Parking accumulation is defined as the total number of vehicles parked at any given time. So the parking accumulation, as I mentioned, this is the number of cars parked at any given time. Many parking studies seek to establish the distribution of parking accumulation over time. يعني طبعا يكون في عندك هنا في variation, and there is peak period, okay, and there is off peak. Parking duration is the length of time that individual vehicles remain parked. So the parking duration, that's the number of hours a car stay in a spot. Okay, and the parking accumulation, that's the maximum number, or that's the total number of parked car in the parking at any time of the day. This shows for us the parking accumulation in urbanized area. Okay, and here the parking duration versus urbanized area. Okay, and that's in the size of the urbanized area, the more it gets, the average parking duration increases. Okay, these are examples for accumulation and duration. Okay, the average duration, hours and minutes, trip purpose, work. For manager, it's around 5 hours and 30 minutes. For employee, it's 5 hours and 59. Please take into consideration that these data are, very old. This is 1972. Here is 1987. So that's most probably that's for our grandparents. So I don't think that these values are still valid for us to use, but you get a sense of it. For personal business, okay, the average duration change, sales, employment, and business, 2 hours and 15 minutes. Again, these values, okay, and especially for shopping, there's a lot of people now that make their shopping online. Okay, so these numbers are doubtful for me. So what we see here, that the accumulation and the duration of parking varies by trip purpose. Okay, the accumulation totals, each column of each field sheet is summed to provide the total accumulation of parked vehicles within each time period in each observer route. You remember these forms? That's when you have the parking based on facility and block, then we add it up and get the total accumulation totals. The duration distribution by observing the license plate records of each space. Okay, vehicles can be classified as having been parked for 1 interval, 2 intervals, 3 intervals, etc. That means we divide the hour into intervals, and you mark if this car is still in that spot for how many intervals: 1 interval, 2 intervals, 3 intervals, and so on. That was the old way of doing things. Now we can use video cam, okay, and use image processing to get this information. Violations: number of vehicles illegally parked, either because they occupy an illegal spot or others. After that, in order to calculate the average parking duration, basically we do the following. This is the number of vehicles parked for X intervals. We do the summation over X. So NX, number of vehicles parked X, multiply X, that's the number of intervals parked. I, that's the interval length, divided by NT, that's the total number of parked vehicles observed. So basically, this is summation of N multiply T divided by N total. Yani here I multiply X give us the time. Okay. The parking turnover, it's vehicle per stall per hour. What do you mean with turnover? Means, how many vehicles change in the same spot. So here NT, that's the total number of parked vehicles observed. PS, total number of legal parking stalls. TS, duration of the study period. So here the total number of vehicles observed parking their cars, and here the total number of legally parked of parking stalls and the time span. So this way we can say, okay, we have vehicle per stall per hour. Okay, that's an example for a license plate check field data for parking study. And as we can see here, okay, we have a time span and we have parking space. So parking space here, 1, it was empty from 8 to 8:30. From 9, it was occupied with vehicle 861, and in the second period, in the third period. Then here it was occupied just only for 1 period by vehicle 136, for 2 period by 140, and so on. You get the idea. Okay, so if we add the summations for all these, we have in the first period we have 6 cars parked, in the second period we have 7, and so on. As you can see, the accumulation here was maximum at 11 o'clock. We had the maximum accumulation. Clear? And also at 9:30. So that's a summary for a field data. Okay, so that's the total spots and the accumulation for interval 1500 total stalls. These are the accumulations, okay, per hour, per time interval. Where's the maximum accumulation? It's here. That was near the threshold, which is 1500. Summarizing field sheets for accumulation totals, and here summarizing field sheets for duration distribution. So the duration distribution for one interval, we had 875, for 2 intervals 490, for 3 intervals 300, and so on. As you can see, it's kind of a negative exponent like this. Okay, but this one is similar to the the peak hour traffic demand. So here, if we want to take this out and go to the sheet here, Okay. Here what we have, you know, what we want to calculate, the average parking duration. What is the average parking duration here? D equal the summation of nx multiply x multiply I. So here we have 875, one interval only. So this is multiply 1, multiply how many? The size of the interval is 30 minutes. So 30 plus 490 multiply 2 multiply, I think we're going to take the 30 common factor and just multiply all by 30 at the end. So here it's 3 multiply 308 plus 275 multiply 4 plus 143 multiply 5 plus 28 multiply 6, and all multiplied by 20. And here the total parkers observed, that's NT, is basically 2119. So basically the average parking duration will be this value, 875 plus 2 multiply 490 plus 3 multiply 308 plus 275 plus 143, 275 multiply 4 plus 143 multiply 5 plus 28 multiply 6 multiply 30 divided by 2119. So the average here will be 54.49 minutes. So that's calculating the average parking duration per vehicle. So that means in this example we have, on average, drivers will park for less than 1 hour. Clear? Now we want to see the turnover. Okay, so here the turnover, okay, is basically the parking turnover rate, the total number of parked vehicle observed, okay, that's NT, BS total number of legally parking stalls, and duration of study period. So this one, let me just check something here. For our situation, we have the total stalls are 1500. Okay, so the TR equals from here, I'm sorry, it's NT divided by PS multiply TS. So that's the study of so the NT, that's the total parkers observed, 2119. And here PS, how many parking stalls? That's 1500. So we have here 1500 multiply the TS. TS is the time span that we had. We had from 8 o'clock to 3 p.m. So this is 7 hours. So here we will have 2119 divided by 1500 divided by 7. So this is going to be 0.202 vehicle per stall per hour. You see that every, so that's the rate. Okay, for each stall per hour there is 0.2 vehicle. That means the demand is not, it's just right. It's not exceeding, the demand is not exceeding the supply here. Any question يا شباب؟ انتوا كنتوا معايا واحنا بنحل على الوايت بورد؟ شباب
ايه يا دكتور؟
لا يعني الحل احنا حليناه على الوايت بورد ولا كنت انا بحل وانتوا مش معايا؟
عد اللي معاك.
ماشي اوكي. طب كويس. في اي اسئله الى الان في هذا الموضوع؟ طبعا انت في الاول هتحس ان الموضوع مكعبل شويه ان الارقام والكده، لكن later on we will يعني you will get at ease with these values. اي سؤال الحين؟ طيب هنقف احنا هنا النهارده. نعم.
واضح دكتور.
جميل.